In this session, let's study three-dimensional solids. As an example, a machine part is a 3D solid. In general, geometrical solids are classified as polyhedron and solids of revolution. A polyhedron solid has many heads or sides known as planes or faces. Regular polyhedron has equal and regular planes. Some of the common types are tetrahedron, cube, prism and pyramids. In tetrahedrons, all faces and base are equilateral triangular faces. A cube has 6 identical faces, each being a square. Prisms are named according to the shape of their bases as triangular, square, pentagon and hexagon. A pyramid is a polyhedron having many-sided planes, base at one end and a point or vertex at the other end. The base of the pyramid may be in different shapes. The other category is solids of revolution, which are generated by revolving 2D planar figures like a rectangle or right-angled triangle about its sides. Most common forms used in engineering drawings are cylinders and cones. A cylinder is a solid of revolution obtained when a rectangle is revolved about one of its sides. A cone is generated by revolution of a right-angled triangle having a circular base and a vertex. So, we have discussed the concept of solids. Now we'll see how the solids are projected with reference to the orientation of their axis. Different possibilities of the orientation of the axis include being perpendicular to one of the reference planes and inclined to the other, or being parallel or inclined to both the reference planes. First, we'll illustrate the case where a regular pentagonal prism of side 50 mm and height 120 mm is resting on HP with its axis perpendicular to HP and parallel to VP. It has two faces A, B, C, D, E and P, Q, R, S, T. Here, its top view will appear as a regular pentagon on HP. Let's draw its projections. For this, first draw a horizontal reference line XY. Below the line XY, we'll draw top view, which is a pentagon with side 50 mm. Observe that top face A, B, C, D, E is visible and base P, Q, R, S, T hidden. The side EA makes an angle of 45 degrees with the line XY. Now, the vertices of the pentagon are joined to the midpoints of the opposite sides to obtain the center O of the prism. From the endpoints of the pentagon, generate vertical projectors. Their intersection points with line XY form the base of the prism. Now, extend projector from the center O long enough to be able to represent 120 mm height of the prism. Then draw line X dash Y dash parallel to XY at a distance of 120 mm. After that, project the base points vertically to intersect line X dash Y dash at points A dash, B dash, C dash, D dash and E dash. Here A dash, B dash, C dash, D dash, E dash is the top face of the prism in front view. So here we are with a complete view of the given pentagonal prism.
The topic of discussion is projection of solids. Well, first of all, we're going to go ahead and we'll try to define a solid. Now, any object, body, or even a geometrical figure which has three dimensions, namely length, breadth, and height or thickness, whatever, that can be referred to as a solid. Alright, so remember this, any object having three dimensions, length, breadth, and height can be referred to as a solid. Now, solid broadly has been divided into two main groups. Now, when you speak of classification, there are two types. One is polyhedron or polyhedra, while the other one is solid of revolution. Now, let me go ahead and write this. There are two types of solids or two main groups. One is what you call a polyhedron, okay? Polyhedron, let me write this as polyhedra over here. And the other one is solids of revolution. Solids of revolution. I'm not writing the entire word. Okay, now this is a big family, solids. Now these are the two main members. Now there are different types of polyhedrons and there are different types of solids of revolutions. Well, first of all, let me make you familiar with polyhedra. Polyhedra is a solid bounded by plane figures or faces, and when those faces are equal and regular, then that sort of a polyhedra is referred to as a regular polyhedron. Now there are different types of polyhedrons. Number one is tetrahedron. So when you speak of a tetrahedron, it has four faces. All of them are equilateral triangles. After tetrahedron is the number of what you call as hexahedron. Well, hexahedron is also popularly known as a cube. When you speak of a hexahedron, it has six faces. All of them are equal squares. Okay. Then number three, it's an octahedron. And from this word octa, you must have recognized that octa refers to 8. So that means it has 8 faces and all of them are equilateral triangles again. After octahedron, the next polyhedra is dodecahedron. It has 12 faces and all of them are regular pentagons. And after this, we have isocahedron. Now this isocahedron has 20 faces and all of them are equilateral triangles. Alright. Now then, 5 have been covered. Tetrahedron, hexahedron, octahedron, dodecahedron, and the last one was isocahedron. Very difficult to pronounce. Anyway, so the sixth spot goes to a prism. What exactly is a prism? Let me read that out. Well, it's a polyhedron again having two equal and similar faces called its ends, parallel to each other and joined by other faces which are parallelograms or rectangles. Okay, and the imaginary line joining the center of base to the center at the top is what you call the axis. Now let me show you an example and then I'm sure that you can understand what exactly a prism means. So if you watch this carefully, this is what you call a square prism. Alright guys, this is the top, okay, and this is the base. Top and base are similar, they are equal, they are parallel. Top and base are joined together with the help of these so-called faces, so-called rectangular faces. If you watch this carefully, top and base are joined together with the help of these so-called rectangular faces. Now the name of the kind of prism completely depends on the shape and size of the top. So if the top is square in shape, you are going to call that prism a square prism. If the top is triangular in shape, then you're going to call that prism a triangular prism. If the top is pentagonal in shape, top and base both I'm talking about, then that sort of a prism is what you call a pentagonal prism, and if it is hexagonal, then obviously it's a hexagonal prism. Alright, now let me make you familiar with a bit of engineering drawing terminology when you speak of a prism. This over here is what you call the corner at the top. This is an edge at the top. This is an edge at the bottom. This is the corner at the bottom. This is the edge connecting the top with the base. This is the face connecting the top with the base. So that is essentially a terminology which I think that you guys should know. Anyways, let me wipe off the sweat. It's really very humid today. Anyways, so we have spoken of as many as 6 polyhedrons, and the 7th spot goes to a pyramid. Okay, so first of all, let me read out what exactly a pyramid is, and then we're going to see the different types of pyramids available. So pyramid is also in fact a polyhedron having a plane figure as its base and a number of triangular faces meeting at a point called vertex or apex. What does that mean? Okay, let me take this example. So guys, if you watch this carefully, this over here is what you call a square pyramid. Okay, you're gonna find them in Egypt. Okay, Google. Okay, so as far as a pyramid is concerned, it has a plane figure as its base, and if you can watch carefully, this plane figure is a square. So this sort of a pyramid is what you refer to as a square pyramid. All right, having triangular faces meeting at the top, which is called the vertex or apex, whatever you can say. This essentially is a pyramid, and to be very specific, this is what you call a square pyramid. Now, if this base, let's say we replace this square with a triangle, then that sort of a pyramid is what you call a triangular pyramid. Let's replace again it with a pentagon, then that sort of a pyramid is a pentagonal pyramid. Let's replace again it with a hexagon, then that sort of a pyramid is what you call a hexagonal pyramid. All right, so that was all about polyhedrons. Okay, so guys, until now we have spoken about 7 types of polyhedrons. We started off with tetrahedron, okay, then hexahedron, then octahedron, then dodecahedron, then icosahedron, then prism, then pyramid. That's it. Those are the 7 types of polyhedrons. Okay, now let's focus our attention on solid of revolution. How can you define that? Well, a solid which is generated or which is developed by rotating a plane figure about a certain axis can be referred to as a solid of revolution. Okay, now let's say we have a rectangle. Rectangle has 4 sides. We keep one side fixed and we then rotate the remaining stuff. What will happen? It will form a cylinder, and that's exactly how a cylinder is born, right? Now the second solid of revolution is a cone. So you have a right angle triangle, all right? So you fix this perpendicular, okay, and then let the remaining stuff rotate. What is it going to form? It's obviously going to form a cone. So cone is a result of the solid of revolution of a right angle triangle, RAT. That's it. Okay, now that we have seen the definition of solids, now that we have seen the different types of solids, let's switch over to the standard procedure. Now this is the standard procedure which we're going to use to work out the projection of a solids. That means creating the front and top views. All right, now you'll see a lot of problems in which the solid may be kept this way, inclined. Okay, its axis may be inclined to HP, its axis may be inclined to the vertical plane also, and there are different conditions that we have to work with. All right, so the standard procedure is very simple. There are 3 steps. Just like in projection of planes there were 3 steps, here also in projection of solids there are 3 steps. Step number 1 is all about assuming initial position. Step number 2, we have axis inclination, and in step number 3 we're going to go for edge inclination. Initial position, axis inclination, edge inclination. That's the 3 steps that we're going to be working with. But the most important step is step number 1, where you have to assume the initial position. All right, so there are essentially 2 cases with which you have to go for the prediction. Axis either would be inclined to HP or the axis would be inclined to VP. Now this axis inclination is something which is going to happen in step number 2. So let me tell you something. Let me tell you the impact of step number 2 on step number 1. Okay, now let us take this case. Guys, this is what you call a square prism. Okay, so if the axis is inclined to HP, that means axis starts from here until we reach here. If it's something like this, if the axis is inclined to HP, then we can assume that this entire solid is resting with its base on the horizontal plane, and then we just got a thing from where we can see the true shape of this. Well, obviously the true shape of the base can be seen from the top, and therefore we are going to begin by making the top view first. That's the entire idea. Okay, secondly, if the axis is inclined to VP, this is the axis from here till we reach here. If the axis is inclined to VP, then what we're going to do is we're going to slam this entire solid resting with its base on the vertical plane, and then again we've got to think from where can we see the true shape of this base. Well, obviously the true shape of this base can be seen from the front, and therefore we have to begin by making the front view first. So that's exactly how you need to approach. And let's say in step number 3 we have to go for edge inclination. So always remember, whichever edge is inclined in step number 3, it initially has to be kept perpendicular to XY. That's it. Now there are certain cases that you have to deal with in which you'll find that the face is resting on the HP. That means it is going to be something like this. Then what are you going to do? In such a case, initially you have to keep it standing. Then again you need to ask the same question to yourself, from where can you see the true shape of this base? Obviously from the top. That's exactly. If the face is resting on the vertical plane, you need to keep it standing on VP. And then again, you have to ask a question to yourself as to from where you can see the true shape of this face, obviously from the front, and therefore you have to begin by making the front view first. So that's exactly how you need to approach for solving problems based on projection of solids. Let me take one more example. Now, as far as this solid is concerned, this is what you call a square pyramid. Okay, the axis starts from the center of this square, that is at this point, until we reach here. Okay, so that's the axis. So sometimes you will be asked that the axis of this pyramid will be inclined to HP. So our initial assumption is going to be like this. We are going to assume that the entire solid is resting with its base on the horizontal plane. Okay, and then you just got to think from where can you see the true shape of this base. Well, obviously the true shape of the base can be seen from the top, and therefore we have to begin by making the top view first. Well, let me change the question. Let me change the scenario. Let us say that the axis is making a certain angle with the vertical plane. What would happen? What would be your initial position in such a case? Something like this. Axis inclined to the VP, either this way or this way, whatever. What you are going to assume is this. You are going to keep this entire solid on the VP, resting with its base on the VP. And then again, you need to ask the same question to yourself. From where can you see the true shape of this base? Okay, the true shape of the base can be seen from the front. Therefore, you have to begin by making the front view first. So always remember this logic. This is going to be very beneficial for you. And if you are successful in creating the correct step 1, then I'm pretty much sure that you're going to go ahead and create the step 2 and step 3 in perfect fashion. Alright. Now, there may be a question in which you're going to be asked that one of the triangular faces of the pyramid is resting on the horizontal plane like this. One of the triangular faces in the pyramid is resting on the HP. In such a case, your initial assumption will be like this. We are going to assume that the pyramid right now is standing on the HP. In such a case, the true shape of the base can only be seen from the top, and therefore you have to begin by making the top view first. That's it. Now, if in the question I say that one of its triangular faces is resting on the VP, what we're going to do is we're going to keep it standing on the VP. Okay, and in such a case, the true shape of the base can only be seen from the front, and therefore you have to begin by making the front view first.
So this is going to be problem number 1, and it goes like this. Draw the projections of a pentagonal prism, base 25 mm side and axis 50 mm long, resting on one of its rectangular faces on the HP with the axis inclined at 45 degrees to the VP. Now let us extract data from this description. So we have a pentagonal prism, alright, and it has dimensions in the form of base and axis. So the base is 25, whereas the axis is 50. Now one more thing that it does have is this inclination. It is inclined at an angle of 45 degrees to the vertical plane. So any inclination associated with the vertical plane is represented by phi, and phi has been given as 45 degrees. Alright, angle made with VP. One more thing, there is this condition that says resting on one of its rectangular faces. So while making its projection, we've got to ensure that one of its rectangular face lies in absolute contact with the horizontal plane, and we have to do justice to this condition. Alright.
So guys, this over here, this solid object in front of you is what you call a pentagonal prism. Alright, it has a pentagonal shaped top as well as a pentagonal shaped bottom or base. Alright, so these two pentagons are regular and both of them are absolutely congruent to each other. So this is the top, base, and this over here is what you call the height of this pentagonal prism. Now, as far as the question is concerned, these are the 5 edges, and all of them are equal to 25 millimeters, and this over here is what you call the height of the pentagonal prism, which is equal to 50 millimeters. Now, we have been asked to solve this problem by ensuring that the axis makes a certain angle with the vertical plane, and that certain angle has been given as 45 degrees. So what needs to be done is, there are certain conditions which are to be followed. The first condition is that we've got to ensure that one of its rectangular faces. Now guys, you can see there are as many as 5 rectangular faces, 1, 2, 3, 4 and 5. Out of these 5 rectangular faces, we need to ensure that one of those rectangular faces remains in absolute contact with the horizontal plane. Alright, so the pentagon, the pentagonal prism has to be oriented in this manner, and at the same time we need to ensure that the axis starting from this point to this point over here
should be kept at an angle of 45 degrees with the vertical plane. So what we need to do is, this is going to be our step number 1. Alright, and the true shape of this base can be seen from the top, and hence you have to begin by drawing this front view first, and then accordingly its top view can be made. So this is going to be the top view, alright, some kind of a rectangle. Step number 2 is going to be by inclining this. So we've got to ensure that this particular prism makes a certain angle with the vertical plane. That angle is 45 degrees. So this is going to be our step number 2, where we are going to alter, or where we are going to modify the top view of step number 1 by tilting or inclining it at an angle of 45 degrees, and accordingly we are going to draw the final front view in step number 2. So that's exactly what we will be doing. Thank you for watching, and let's now head over to drawing sheet, and I'll head over to AutoCAD to explain you how all these things can be implemented. Thank you.
So guys, now that you have seen the orientation, let's start by drawing the pentagon. And you have already seen how the pentagonal prism has been kept in this way. Alright, so we are going to start from this. We are going to draw this front view in the shape of a pentagon, and then we are going to create its corresponding top view. So we are going to be starting with drawing this pentagon in the front view, and then its corresponding top view will be made. So let's head over to AutoCAD, where I'll be showing you as to how all these things can be implemented. So we have this line over here, an XY line. You can clearly see this, and then I'm gonna draw one more line from here at an angle of 108 degrees. So this line is going to have a length of 25 millimeters at an angle of 108, and then same stuff, this internal angle is going to be 108 degrees. That's it. Now the next thing to do, guys, is we need to put two arcs, one from this and the other one from this. Alright, so we're gonna put in a 25 millimeter arc. Okay, and this arc will be cut by another arc whose center is going to be this point. That's it. So this is the intersection point. You can clearly see this, and what we're going to do now is we'll join this intersection point with these 2 points on its extreme left and extreme right. Alright guys, so now this is what you call a pentagon, and let's delete this construction process, and I'll be darkening all these points. Okay, fine. Now there are 5 corners at the front and 5 corners at the back. I'll show you the figure. 5 corners at the front, and similarly we have a pentagon in the back side also. It also has 5 corners, so we're gonna name them. So front 5 corners will be named by 1 A B C D E, whereas the back 5 corners will be named by 1 2 3 4 5. All right, so guys, now that we have created the front view, we are now going to draw its corresponding top view, and for that we are going to look at this object from over here, that is from the top. Okay, that's why I've made this arrow. Now let us keep this pentagonal prism at a certain distance away from the vertical plane. Let us say the distance is 2 centimeters. All right, so let's do this quickly. Okay guys, you can see this distance has been taken as 20 millimeters. Okay, now this is obviously, this was 25, you all know that. Fine. Now I'm going to bring these so-called projector lines downwards. Somewhere here. Well, that's it. I'm going to chop off this portion. All right. Now the next thing to do is to draw this. Okay. Now this length, this is the overall length of the axis. We need to check as to how much the length is. The length of the axis is given as 50 millimeters. All right. So we need to draw a line over here. $50 millimeters. All right. That's it. Let's finish this. Now guys, please have a careful look at this. This is the edge 1A, this is edge 5E, and this is edge D4. These 3 edges will be seen as solid lines from the top. So these are the solid edges and can be seen. Okay, and as far as these 2 edges are concerned, 2B edge and 3C edge, they won't be seen. Okay,
So the edges which can be clearly seen are to be drawn darkened up. Okay, so those edges are 1A, 5E and 4D. All right. Even this one, the middle one. Now these edges cannot be seen directly, but in order to make their presence felt, we'll give them some respect. And for that, what I'm going to do is I'm going to mark them by hidden lines. Exactly, something like this. Now this is visible, this is visible. This appears as a line, but in fact this is nothing but a pentagon. All right, it appears as a line. Let's darken them. Okay, so the front 5 corners were A, B, C, D, E, whereas the back corners were 1, 2, 3, 4, 5. That right? So the front corner A, this is A dash, and its corresponding top view will be somewhere here. So this is going to be A, simply A. And similarly, this is, if this is B dash, this has got to be B. This is going to be C. This over here is obviously, this is D. Okay, so its corresponding top view is D. And this finally, guys, we have this E. Its corresponding, this is E, and its corresponding top view will be somewhere here. Similarly, we will do the numbering for the back side pentagon also. So this is the pentagon at the front, and this one is the pentagon at the back. So we have this A, B, C, D, E in the front, and 1, 2, 3, 4, 5 at the back. So this over here is 1. This has got to be 2. That's 3. That's 4, and finally we have this as 5, right? So we've now successfully created step number 1. Now let's head over to step number 2, where we are going to incline this. Okay, keep this top view at an angle of 45 degrees. Okay, that's exactly how this pentagon is going to be kept. This edge over here, it would appear from the top view that this edge is making a certain angle with the vertical plane, and that is in fact, I guess, 45 degrees. All right, if the axis makes a certain angle, then all these edges are going to make the same angle with the vertical plane. Now you guys can see that I've made this line, and I'm going to recreate this figure. All right, so I'm going to make a point over here, and this, guys, is what we call 0.5. Please watch this carefully. This is an extremely important step. I'm going to zoom on it. Now this length is actually 50. All right, so with this guy as center, I'm going to put up an arc of 50. All right, so now I have it, this point as E. Okay, so now I have got 5. Now I've got E. I need to locate A, B, C and D. Okay, it's going to be pretty simple. Please watch the steps carefully, and you will be through with no real fuss. Right, so that's 5E. Now the next thing to do is to you see these lines. Okay, so these lines are actually pretty much what do you call, at a 90 degree angles with this line over here. So these lines are at an angle of 90 degree line to each other. So what I'll do is I'll make lines over here at a 90 degree angles to this line over here. Fine. Okay, so let's see how that can be done. All right, so what's the next step? You need to take arcs from 5 to 3. So 3 will be somewhere here, and then from 5 to 4, or you can also take an arc from 3 to 4. Okay, I'm going to show you right now to locate 5 to 3 and from 5 to 4. It's going to be pretty simple. Please watch them carefully, and for that you need to take an arc from 5 to 3. Okay, you can use a compass for this. This is working out as 13. All right, so what I'll be doing is, okay, so that's an arc. Again, I'll be putting one more arc. Now this is going to work out as, I guess it's going to be 20. All right. So now that we have put up those arcs, so this is going to be 0.3 obviously, and this is what you call 0.4, right? Okay guys, the next thing to do is to repeat the same process of putting up those arcs for over here, over here, over here. Okay, I'm going to just copy this, and finally it should look something like this. All right, now let's join all these points. Now let us darken all these lines which are perfectly visible from the top, and these are what you call the hidden lines, broken lines. All right, so right now I'm going to chop off the portion which is not desired. This way, this way. So fine guys, this is how you can actually recreate the top view from step number 1 into step number 2 by ensuring that it makes a certain angle 45 degree with the vertical plane. So that's exactly how this task has to be accomplished, and now I'm going to write them. This is point E and this has got to be point A. Then next thing to do is to draw vertical lines from this object over here and to draw horizontal lines towards the right. Okay, and finally these lines are going to intersect at different points. So the horizontal lines are almost done. I mean, this line accounts for 5 and E, and this line over here accounts for 4D, 1A, and this line, already drawn line, the XY line overlapping, accounts for 2, B, C, and 3. Fine. So right now we're going to draw these so-called vertical lines from, let me first write the name of this point. This is 1, this is 2. Okay, so let's start by drawing these vertical lines. That's it guys. Now our task is almost done. The next thing to do is to locate 5 points at the front and 5 points at the back. Now one thing is for sure, that this pentagon over here, when you look at this object over from here, I'm going to draw an arrow. So when you look at this object from here, okay, so this pentagon ABCDE pentagon will be evident. Alright, although its true shape will not be evident, but the pentagon will be in some kind of squeezed manner. It would appear as if it is squeezed or compressed laterally. All right, so we have this this vertical line for A, and we have this horizontal line for A, and both these lines intersect somewhere here. So I'm going to write here this vertical line for A and this horizontal line for A. So this is going to be A dash, obviously. Now similarly, this is going to be, this vertical line is for B, you can clearly see, and this horizontal line is for B. So they intersect somewhere here. So this is going to be for point B dash. All right. Similarly, we have this as C dash. Now we're going to join all these points with the help of a dark line. In fact, let's do this quickly. Now guys, one thing is for sure, that this pentagon can easily be seen from the front. Okay, this pentagon can be seen, and a particular portion of this pentagon can also be seen from 5 to 1. All right, so we are now interested in locating these points over here, and this line is for 5, and you can clearly see this horizontal line is for 5. So over here we are going to have point 5 dash. Now let's locate 1 dash. So this line, horizontal line, is for 1, and this vertical line is for 1, this horizontal line is for 1. So we have here 1 dash. Similarly, you can figure out this point as obviously 2 dash. This over here is 3 dash. That's 4 dash, and finally we have this. Now let's speak of these so-called these edges from A to 1. So the edge from A to 1 will be seen, okay, it's evident. So the edge from E to 5 will also be seen, okay, E to 5. I'm talking about this edge, E to 5. Alright, so let's make this edge a bit darker. Edge from A to 1 can also be seen easily, so we're gonna make it darker. At the same time, edge from B to 2 will also be seen. Let's make it dark. And finally, as I said, that this 5 1 2 portion of this pentagon can also be seen. So we're gonna darken this. Okay, so that's almost done, and we now have in front of ourselves a pentagon which has been kept an angle of 45 degrees, ensuring that one of its rectangular faces lies entirely in the horizontal plane. Okay, so these are the solid lines which can be seen directly. The ones which cannot be seen are to be given some respect in the form of drawing the so-called hidden lines. So we're gonna join this 5 dash with 4 dash, 4 dash with 3 dash, and then over here what I'm gonna do is I'll make a line, especially this D4 line. So this some portion of this D4 line is lying behind this solid line, so nothing can be done. But as far as this much portion of the line is concerned, we're gonna make it hidden. This one also will be made hidden, and on doing so it should look something like this. Please watch carefully. That's it. That's almost done. Let me write the angle over here. So this is obviously 45 degrees, and that's it, guys. This dimension is also left. Let me do this. So this is actually 50 millimeters if I'm not wrong. Yeah, pretty much. So one arrow from top to bottom because we drew the front view first, and then the other arrow from bottom to top because we drew the top view in step number 2 initially, and then its corresponding front view was made.